Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this short video is going to deal with negative binary arithmetic or negative binary numbers. Okay? But I suppose as a way of trying to rationalize what's going on behind the scenes, let's just take two decimal numbers. Okay, let's take 100 and let's say 114. Okay, in base 10, and let's take away from it 114 in base 10. Now we know that 114 minus 114 in decimal is equal to 0 in decimal. Okay? Now the question that we really have here and we're trying to deal with is this, is that we can convert 114 into binary, okay? But is it possible to convert minus 114 also into binary? And that when we add the two binary representations, the first of the positive 114 in binary to the negative 114 in binary, do we get 0? Okay, and there's a technique for doing this using what's known as the ones complement and twos complement versions of binary numbers, and we'll do that now in a moment. But first of all, let's convert 114. Let's convert positive 114 in base 10. Let's convert that to binary. Okay. So to convert to the binary, what we'll do is we'll continually divide by 2, keeping track of the remainders. So we're going to have 114. That needs to be divided by 2. 2 into 1 won't go. 2 into 11 goes 5 times, carry the 1. 2 into 14 goes 7 times with a remainder of 0. Let's divide 57 by 2. So 2 into 5 goes twice, carry the 1. 2 into 17 goes 8 times with a remainder of 1. Let's divide 28 by 2. 2 into 2 goes once. 2 into 8 goes 4 times with a remainder of 0. Let's divide 14 by 2. Well, 2 into 14 goes 7 times with a remainder of 0. Let's divide 7 by 2. Well, 2 into 7 goes 3 times with a remainder of 1. Let's divide 3 by 2. 2 into 3 goes once with a remainder of 1. And let's divide 1 by 2. 2 into 1 won't go with a remainder of 1. Okay, so as a binary number, positive 114 is this sequence of binary digits here. Okay, it's a sequence of remainders, and most importantly, the most significant digit is here, and the least significant digit is here. So let's represent this number. Let's represent it as an 8-bit number. Okay, so we'll take the first 4 bits from the least significant digit. Well, the least significant digit is 0, followed by a 1, followed by a 0, followed by a 0, followed by a 1, followed by a 1, followed by a 1. And I'm just going to pad that out to be an 8-bit number by putting a 0 on the end here. So what we're arguing now is this, is that this binary string, which we know from our previous videos, that this binary string represents the positive number. It represents the positive 114, okay, in base 10. Okay. Now what we'd like to be able to do is we'd like to be able to now take this binary number here, okay, which represents positive 114, and convert it into a negative 114. And there's a way we do that, okay? So what we're going to do is step one, okay, is we take our positive, okay, binary number, okay, and we create what's known as the ones complement. We create the ones complement version. Okay, now that's very straightforward. All we do is well, let's rewrite down our binary string. It's 0, 1, 1, 1, 0, 0, 1, 0. So to create the ones complement, what we do is we process from left to right, converting zeros to ones and ones to zeros. Okay, so when we do this here, 0 goes to 1, 1 goes to 0, 1 goes to 0, 1 goes to 0, 0 goes to 1, 0 goes to 1, 1 goes to 0, and 0 goes to 1. Okay, this number here is the ones complement. Okay, so let me just put that down there. Okay, so that's step 1. Now step 2, okay, we create the twos complement number. complement. This is a process, okay? And the way we do that is by we take the ones complement number, okay, and we add on the binary number 1 to that number. So let's do it. So let's take the ones complement. So the ones complement is 1, 0, 0, 0, 1, 1, 0, 1. Now we got that by taking our binary string and just flipping zeros to ones and ones to zeros all throughout the string. Okay. So what I'd like to do now is I'd like to add on to this ones complement number the number 1. Okay, well the number 1 in binary is 0, 0, 0, 0, 0, 0,